trapezoidal rule is a first degree Newton-Cotes approximation of a definite integral. Suppose that we have this graph of the function f, and we want to integrate f over the interval a to b. Let us suppose we partition AB into a certain number of subdivisions, say 1, 2, 3, 4, 5, 6, 5 in this case. These points that subdivide the interval a to b are equispaced. Then what we do is we erect the vertical lines up to the curve from each of these points of partition, and then we create trapezoid everywhere, trapezium everywhere. So this will be the trapezoid here. So these are the various trapeziums. Now we know that the area of a trapezium which has parallel sides are like A and B, and the height is, this is h. It is given by, the area is given by 1/2 A plus B times h. So therefore, if these are the points x0, x1, x2, x3, x4, x5, x0 is the same as the x-coordinate of A, and x5 in this case is the same as the x-coordinate of the point B. Then, for example, the area of this trapezium is given by, and let us suppose that the width, the common width here, is equal to h or w. So let's put it as h, and it'll be this length will be f of x0, and this will be f of x1. So this area will be given by 1/2 h times fx0 plus fx1. Similarly, we can create all these areas, these expressions for these areas of the trapeziums. And so, for example, the total area counted by using these trapeziums will be 1/2 h fx0 plus fx1 plus 1/2 h fx1 plus fx2, and so on and so forth. And the last one will be 1/2 h fx4 plus fx5, and this will be h over 2 times f of x0 plus 2 times f of x1 plus 2 times f of x2, and so on, 2 times f of x4 plus f of x5. So in general, if there are n subdivisions in the partition, then we'll find that the formula for trapezoidal rule is multiply the half of the width, which is h over 2, with an expression that is the values of the function at each of these points of partition. The first and the last is these are the values themselves, the values of the function, and the ones that are in between, the intermediate ones, these values are all multiplied by 2. So therefore, the formula is h over 2 f of x naught plus 2 times f of x1 plus 2 times f of x2, so on, 2 times f of x n minus 1 plus f of x n. This is the trapezoidal rule. Simpson rule is a second degree Newton-Cotes formula for approximating a definite integral. In this method, the interval of the definition of the definite integral is partitioned into an even number of partitions, and then two consecutive subdivisions, even number of subdivisions, and then two consecutive subdivisions, which give us 3 points on the curve, are used to pass a parabola through them. Therefore, the curve is approximated by a parabola, which is a second degree function. That's why it's a second degree formula. A parabola is a quadratic function, so it is of the type ax squared plus bx plus 3c, and so has 3 unknowns, and they can be determined if we have 3 independent conditions, for example 3 non-collinear points. So therefore, here, for example, we take the first and the second subdivision, so this gives us correspondingly 3 points on the curve, and we use these 3 points to generate a parabola that passes through these 3 points. And therefore, the curve between A and this point, this point A and this point, which is actually equal to this, is approximated by a parabola which was shown in green originally. Then we go to the next 2 points, for example, next 2 subdivisions, and we get 3 more consecutive points after this, and so we generate another parabola that passes through these 3 points. So for example, the one that is originally shown in the purple, this is the other parabola. So we find out the areas of the portion which is generated, which is bounded by a parabola, and over and the x-axis, the algebraic area. We find that in each case and add them up to find out to determine the formula, Simpson rule. Now it is known, because the middle point is the midpoint on the x-axis. This is the midpoint of these 2 points. It can be easily shown that the area, the integral, or the algebraic sum of the areas bounded by the parabola generated and the x-axis, is actually given by h over 3 times the first function value at the first point plus 4 times the function value at the middle point plus the function value at the third point. So for example, if we call this as point x0, x1, x2, x3, x4, then the next one will be x2, x3, x4, the next 2 subdivisions, and that'll be given by h over 3 f of x2 plus 4 f of x3 plus f of x4. And in this case, if we add them up, we get h over 3 f of x naught plus 2 times f of x 4 times f of x1 plus 2 times f of x2 plus 4 times f of x3 plus f of x4. In general, if we have n subdivisions, and as we can see that the Simpson rule requires n should be even, n is even, then the formula will, and h is the width, then the Simpson's rule in the general case will become h over 3 times f of x naught plus 4 times f of x1 plus 2 times f of x2 plus 4 times f of x3 and so on. It'll be 4 times f of x n minus 1, and before that the term will be 2 times f of x n minus 2 and then plus f of x n, and this is the formula for the Simpson rule.